Hi, Professor. Hope you are doing good. I am Sai Manoj Mekapati, and in this video, I'll be explaining on image classifier assignment. So, in this image classifier, I'll be considering three different categories of images. I'll be tagging each image for the respective category. I'll be training the model, validating, evaluating the results, and I'll be analyzing what all predictions that I have been viewed in this whole model testing and training. So in order to do that, firstly, I'll be creating a model. I'll be creating the project in customvision.ai. So yeah, I'll be providing the name as image classifier and the description as image classifier assignment 1. And the resource, we need to create one. I have already did by providing the name, subscription, resource group, kind, location, and pricing tier. I have already did that, so I'm selecting the resource as student learning, and the project type is a classification, and classification type is a multi-class where each image has only one tag. So and domains are general A2. Image classifier 1, I am changing the name as image classifier 1, and I'm creating the project. So, firstly, we have to add all the images for the respective categories and we need to tag them accordingly. Firstly, I'll be adding bike category images, and I'll be tagging with bikes and I'll be uploading them. Secondly, I'll be adding the images of second category, which is boats, and I'll be tagging them with boats. And I'll be adding the other category which is dogs, and I'll be tagging them with that respective category and I'll be uploading them. Yeah, so now I have loaded all the images from those respective categories and I have tagged them accordingly. So we have five images across each category. So now we're gonna train this using the train here, like by clicking on the train button. Here we have two types of trainings. One is quick training and advanced. Advanced is mainly used for the larger, huge kind of data sets. Now we have only limited kind of data, which is five images across each category. We're gonna go with quick training. So in this training, it gonna use the machine learning model called supervised learning. So this model learns from labeling the images. So it uses the deep learning technology, which is CNN networks, I mean CNN, which are designed for image classification. They automatically extracts important features like shapes, edges, textures from the images. During the training, the model looks at many of the examples that we provided, like images that we provided, and they learn to recognize the patterns that belong to each category that we provided as a tag for each of the images. So, once the training of these all the images across three respective categories or tags is done, we're gonna do a quick test by performing the by getting the predictions by providing the new set of images uh, from those respective tags. Let's see that further. And this is the project gallery page, and this is the name of the project. And we have three kind of tabs. One is training images, performance, and prediction. In the training images, we have all the images that we have uploaded and the respective tags for that. And in the performance, it gonna give us the model performance for all those that has been trained under. And in the predictions, we're gonna get all the images, we're gonna perform a quick test or validation on the training data set using the training data set. So here we're gonna wait for few more minutes to get the precision, accuracy, average precision, and also recall values for all those images that we have used for the training in this model. And coming to the assignment in this requirements gathering. So in this requirement gathering, we have covered uh, different categories we have used and tags, training the model, validating, evaluation, and analyzing all, and regarding this, analyze all steps you performed and think how should the behavior of enterprise solution with the same purpose, what are the difference. So the mainly while loading the data set, the difference between our purpose, we have used only the limited kind of data set, but in the real time real world enterprise systems, they would be using the automated AI assisted labeling rather than adding them manually, because they used to handle millions of images, uh, rather than like how we perform like just a sample of 5. And coming to the training the model, large scale companies they gonna use the GPUs accordingly or cloud based distribution computing to train the model faster. And also validating, regarding the validation step that we performed here. Yeah, regarding the validations, I mean that gonna perform next. So now the I think the model training is done, where we have the precision recall and average precision values, which is 100%. I think it's most probably because of less data set and overfitting, because it just guesses the similar kind of images across all tags. So that might be one of the reason we are getting 100%. So let's gonna quickly test it out by providing different kind of image which is not included in the training. So I have different kinds of images apart from the images that I have loaded for training. So once I perform the quick test, it gives us the predictions for that image, new image, which shows 99.9% probability for this image. And we're gonna perform on two different images as well, other images. So it's gonna give us the boats as 99.2 and other as the negligible values. It's because of the extracting similar kind of images. Here it extracts, yeah, it extracts dogs as 81%, boats as 18%, because it extracts the outlier or the features of the dog. So it gives most of the prediction probability for the dogs. And let's, yeah, that's what we have given a quick test on. And so in these predictions we're gonna see what all images we have predicted and those probabilities for the same. Yeah, mainly this use case that I have used, it's mainly helpful for large scale industries which gonna handle huge amount of data for classification, like for classifying the images. It's gonna help us by assisting them by automating the AI assisted labeling. Yeah. Thank you, Professor, for giving opportunity to work on this assignment image classification. Thank you.